Then 7, I got C.
Seven, you said you got what?
On 7, I got C.
Okay, so I'm confused on this one. How do you figure this out?
So on this one, we do the 1.96 times 0.01 divided by n, and we don't know what n is. That's what we're trying to figure out. So if you punch those numbers in as n, we get 38,416, which equals a margin error of 0.0001.
So give me that equation.
So that same equation we were just talking about.
Oh, really?
Pretty much what we use. So you use the z-score times sigma divided by the square root of n.
And we don't know the square root of n right?
And yeah, you don't know what n is, but you use one of those numbers. Or if they don't give you options, you can just randomly punch in numbers until you get your, what is it, margin of error? Yeah, until you get your margin of error to be 0.0001.
Wow. Lost one. It's confusing.
Did you say you were lost?
Yeah.
So you take, so the equation is E times sigma divided by the square root of n.
Okay.
So the z-score is 1.96, 95%. And then, and we know sigma is 0.01, and it's n we just have to figure out. So if you just put these numbers in as n, you'll figure out what your margin of error is.
96.
So if you do 1.96 and then times 0.01 divided by the square root of 38,416, that gives you 0.0001.
Oh, yeah. I got it. That's not that bad. That's easier than I thought.
And if you're curious, that's in lesson 10.
Okay.
All right, are we good for that one?
Yeah.
Perfect. So number 8, we just have to figure out a hypothesis test for this. And I think the first one, A,
Okay.
is the 10 agreement that it's smaller than the advertised.
So yeah, did you say A?
Yeah, I think it's A.
Yeah, me too.
I agree.
You agree, Ben?
Yeah, I do.
Perfect. So 9, I think the
You said you could what?
B.
As in boy?
Yep.
Okay.
The p-value is less than A.
Yeah, that's you reject the null. So that's less significantly. Okay.
Then 10, I think is A. Because since it's a completely random sample, it meets criteria for NOVA.
Yeah, and there's several means they're trying to figure out. Right?
Yeah.
Okay. So it's A.
Yeah, we'll go A as an apple.
Okay.
Then 11, I got A also. And it's type 1 because she rejected the null when it was true.
Oh, that's right.
So she rejected the null, but it was wrong. So it is
She rejected it, and the null was true. And since she rejected the null and it was true, it's a type 1 error.
Yeah.
And the next one will be
It'd be what?
D as in dog.
Yeah, because they just teeter-totter. If one goes up, the other one goes down. Right?
Exactly. So this one, we use the equation to find a simple z-score with sigma known. And we have to use normal probability applet.
So silly question. I don't remember what the equation was exactly we have to do for this for z.
That's okay. So it's z value minus mean. So x minus u
Okay.
divided by the standard deviation, and that's sigma divided by the square root of n.
Divided by the square root.
So for this one, 1.53 minus 1.5 divided by 0.17 divided divided by the square root of 100. And that gives you your z-score.
Oh, yeah.
Sorry, that should give us 1.765. And you put that in the applet and shade to the right, and that gives you 0.038.
So did you say you got 1.765?
Yeah, 1.765 is the z-score.
Yes. Right.
Put that in your applet shade to the right, and you get a P of 0.038.
You said you get a probability
Of 0.038 when you put it in the applet.
Okay.
And since that's less than 0.05, we would reject the null hypothesis.
Yeah. All right. I remember now.
So that one's. Are we all on the same page with 13?
Yeah.
D.
D is in dog.
Okay.
Okay, and for this next one, I think it's independent samples t-test.
Yeah, I do too, because they're not correlated with each other, they're dependent on each other.
Exactly.
What's a paired sample? How do you know that?
So the paired sample is like the pre-test and post-test, comparing the differences. Where one category, so if someone's in A, they're automatically in category B.
Okay. I see. Great.
So here's a good example. This next one is sampling or dependent. So it's D because the brothers and sisters are relying on each other.
Okay. Well, that makes more sense.
So because she decided brothers and sisters raised in the same home, you select a brother whose sister is automatically placed in there too. Must include the sister in your study or else your data is not congruent.
Yeah. So that's yes, dog, right?
Yes, sir. Okay, and so for these next ones, we use the one program, SPSS.
Okay. Yeah, Ben, that made a ton of difference putting on those headphones.
Oh, good.
Thanks.
Yeah, thanks for doing that. It's easier on our end.
But I was finally noticing the volume indicator every time you guys would talk would go up on my screen.
Yeah.
So,
You just must have a really touchy speaker or a microphone or whatever it's called.
I think it's because the mic's pretty close to the speakers.
But that's okay.
Yeah. Sorry, I'm pulling up SPSS right now.
Oh, so this first one for 16 you don't need SPSS for it.
Oh.
But I mean, once you put all the information in, I think it's B, because you have information, but sigma is unknown for it, and there's only one mean. So I think it's B, but you guys can once you get it pulled up, you can be your own determining factor, obviously.
You said you think it's what?
B.
Because the sigma is unknown.
Yeah, we don't know sigma when we do the calculations.
Even with SPSF, we couldn't figure it out?
But we just don't know it beforehand once we put it in.
Oh, yeah, okay. That makes sense.
And you kind of have to figure that so you know which little thing to run with SPSS. Not that this one's too hard to run, but
Yeah.
so for this one we just have to do the analyze, descriptive statistics, and explore. And that'll give us our 95% confidence interval for the next one. But yeah, yesterday when I was reading back on this, it says most cases in real-world scenario, you don't know what sigma is.
Yeah.
So you do your confidence interval when you know your mean, but you don't know sigma.
So 17, did you get D as in dog?
Yes, the 11.168 and 15.217.
Yeah. That's what I got. So on 18, we got to pull up a different one then.
Yeah. It's lovely. You have to pull up a different one for every 2 questions, it seems like.
Yeah.
All right, so for 18, I think we use the independent sampling because it's comparing 2 different means. It's comparing the means from the cells of Los Angeles Hummers to the New York Hummers. So you have 2 Hummers, so you have 2 groups. So it'd be confidence intervals with difference of means using independent samples.
Sorry, what is this data file we're supposed to be pulling up?
It's called Used Hummers, LA and New York.
That's why. Okay. Sorry.
No, you're good.
Okay, and this
Gives you a page full of random data, a bunch of stuff. And so in this one, we'd have to do the automatic recode for the different cities.
Yeah. So, let's see here. For the cities, we're doing it?
Yeah, because the cities are the two categories you'd have to automatically recode.
Where are the cities? What?
So if you scroll over, they're farther right.
Ah, I see. I didn't see them. Okay.
And so that's why I think it's the confidence interval with difference of means, independent samples, because you have to recode it, and that's like one of the few ones where you have to talk about recoding other than ANOVA.
Yeah. So you did. Okay.
And then once you do your recode, then you can do the independent samples T.
Independent because they're not associated with each other?
Exactly, because they're different cities and you're just comparing the data. So your test variable is the price, and your grouping variable is your city code that we create.
Yeah.
And you have to define the groups, and then it gives you your 95% confidence interval.
Okay. So, so Ben, on 16 and 17, were you able to get either of those? Or have you done those?
Sorry, I had to run out. My dogs were outside freaking out. I had to go out and grab them.
Oh, you're good. I didn't even notice you were gone. I had my screen minimized. Sorry.
Oh, no, you're good. No, there's a squirrel that torments them, but then they're just so loud and annoying.
You know, that's squirrels that torment and harass my dog like crazy, too. She caught one of them, so put an end to that. So where are you at, Ben? How far ago did you leave?
Oh, I'm on 17. I'm just trying to get all that data put in. Which one are you guys on?
We were just about to do 19, but we'll wait for you till you get back. Catch
No,
up.
we can go ahead and just go there. That's okay.
All right. Well, with 17, we got D, 11.168. Right? That's what you got, Jeff.
Yeah.
Okay, just making sure.
And then when you use the SPSS, you go to Analyze and Explore, and it gives you your confidence interval, and that's what it is.
Oh, okay.
Yeah.
And then for 18, we chose the confidence interval for difference means using independent samples.
Mm-hmm.
And our logic behind that is because you're comparing two means, and they're independent from each other because they're from two different
cities.
locations.
Okay, yeah, that makes sense.
And that's where we're at.
Perfect.
So, on 19, do we always just choose the bottom number when we're looking at for lower and upper? Because, you know, it gives you two of them.
Yeah, it says in the reading, because I looked it up because I couldn't remember yesterday.
Yeah.
It says in the reading for our class, we always choose the bottom number. The equal variance is not assumed.
Okay. Because I couldn't remember that. I know I missed that on one of the homework assignments because I was like trying to compare both of them, which is definitely the wrong thing to do. So, all right. So I got C. Is that what you got?
Yes, the -423 and then the 5417.
Yeah.
And then Ben, we were talking about this one while you were gone too, I think. For this one, you'd have to get all the data in, which gives you a bunch of data in the screen.
Okay.
Once you load that data file, and then you have to do an automatic recode for the cities to organize the cities between Los Angeles and New York. And then you do the analyze, compare means, and independent sample t-test. That's if you use SPS. I don't know if you use SPSS or Excel.
I tried to do it all in Excel, but...
Oh, cause, yeah, I haven't been able to use Excel, so I wouldn't know how to do it there. Sorry.
No, you're good.
I'm going to get the other data file loaded here.
Okay.
All right, when everyone's ready on 20, just let us know.
Yeah.
So in this one, are we comparing three different things? So would it be ANOVA because there's several, or no?
Yeah, you'd have to use ANOVA because there's two or more.
Okay.
Since it's more, it has to be ANOVA. So for SPSS, you'd have to do the automatic recode for your treatments. And then, yeah, you just run the ANOVA, one-way ANOVA code, and you get what you want.
Yeah.
And make sure you go into options and select descriptive and means plots. I think that's what she told us to do, and it gives you all the information we need. I guess means plot you don't really need, but...
So you said, I still got the right answers, I think, for the next two, but where I got it differently. What did you do, or did you say to do it?
So once you have your data set,
yeah,
you run a automatic recode.
Yeah, I got that.
And then you go, then you hit analyze, compare means, and do the one-way ANOVA.
Yeah.
And one of the options, I know in the reading it talks about selecting descriptive statistics.
Okay.
Then you hit OK and run that with your data, and it just gives you a little more information.
I see. And oh yeah, and she said mean plots. I remember her saying that now.
Which I don't know why, because I don't think we've ever used the means plots down below it, but whatever.
Yeah, probably coming up in a lesson or two.
Yeah. So 21 should be C, 7.97.
Yep. And then on 22, I mean, I got B, but is it just a one? It's a two-sided test, right? So
when you use ANOVA, it's always, you don't ever cut it in half. I do remember that.
Okay, good to know. Good to know.
It's when you do the other ones, if it's a one-sided test, you divide it in two. But with ANOVA, you never divide it in two.
Great.
Why? I don't know. I just remember learning that.
That's okay. Sounds good.
And then for 23, you know, 23 is one of them I wasn't sure. I think it might be A, but I honestly, I don't know.
So, wouldn't it be, okay, so I chose B, but I'm probably wrong. But, so this is
I honestly don't know, so that's why I...
The only reason why I chose it, just from like previous, so usually if we're doing this, we're trying to prove that the null hypothesis is wrong. And so we have sufficient evidence that at least one of the groups is different from bone density of at least the other one of the other ones. Because isn't that what we're trying to find, if it's if it's different?
Because I went back and I'm not exactly sure what the null hypothesis would be for this, and I just don't know.
So yeah, I think it's the researcher would like to determine if the mean levels of bone density are different between the three. So we got, I mean, we're trying to figure that out, and we've got a p-value less than 0.05.
So your null hypothesis would be that nothing makes them different, and then he's trying to prove that it does. So his alternative hypothesis is that exercise makes them different, right?
Yeah.
Okay.
So that's why I choose B, but I don't know. That's just...
So yeah, thinking of it that way, I think you're right. Because at least one of them would be different because you would reject your null hypothesis.
Yeah.
Okay. I agree, B. What do you think,
I agree as well. It'd have to be.
Yeah. Okay.
Yeah, when they start wording them, I get confused.
Oh yeah, no, totally with me too.
All right, then. Down to 24. So this one we actually had in a quiz a while back, and it's almost identical.
Oh, really?
So it's a dependent sample t-test because you're trying to see the difference between the 90 days and the 14 days.
So dependent sample, is that the same as a paired sample?
Yeah.
Okay. I was getting so confused. I was like, I don't know.
Because what's in category A, what's in B depends on what's in A.
Okay.
And independent is when doesn't matter. It doesn't, what's in A does not determine what's in B.
Okay. Oh. And when you're doing the SPSS thing, don't you, like when you're doing the paired sample, don't you put 90 days in variable 1 because it's got a minus from the pre-test? Post minus pre?
Yeah, so you do 14 minus 90.
Oh, is it 14 minus 90?
Yeah, because 14's the pre. I mean, 14's the post.
Okay. I thought it was backwards than that. Maybe let's see. Okay, so you said 24. That's a dependent sample test because they're associated with each other. Pre and post. Okay, calculate the test statistic.
So yeah, so you go in and you do the compute variable.
Where's that?
So
right
you
there.
go transform.
Whoa.
Do you remember doing this?
No, not this. It looks way different.
So I think I figured out this one from one of the videos. You create a new variable. So you do 14 days. So you click on 14 days and move it over into the numeric expression box.
Okay.
Hit the minus sign on your keyboard, and then move over the 90 days. So it's 14 minus 90.
Okay.
And then your target variable, you type in difference and hit OK, and it gives you the difference between the two of them.
Oh, yeah. I remember doing this. I just chose to do it the other way because this one was confused me.
Yeah, I don't know the other way, so.
Well, let's see if we get the same thing. Maybe my way is wrong. So, what did you get for 25?
Here, let me get there 1 second. So for 25, I got 1.685.
Yeah, so we get the same thing.
We just go different ways of getting there.
Yeah, so all I do is I just go into the analyze, compare means, and just go down to paired sample.
Mm-hmm.
And then I do 90 minus 14 days.
Okay.
Or maybe let me see if I can do it the other way and see if it gives me the same thing. Because you can just stick the same thing over there. Yep, you get the same thing.
And then I got a p-value of 0.096 for 26.
Yep, that's what I got too.
And so for 27, we just have to figure out what the right wording is, which I think it's B, but obviously I'm not very good with these ones. So I think there's sufficient evidence to conclude that there is a difference in the costs between tickets purchased 14 days in advance and compared to 90 days in advance.
So, let's see. What's the null hypothesis of this?
So I would think the null hypothesis is there's no difference, and your alternative hypothesis is that they are different.
Okay, so the only, I don't know, with it, so the level of significance they give us is 0.10, which is higher. Oh, no, never mind. I agree with you. I was wrong. I was looking backwards. Evident to conclude that there is a difference. Yes, I 100% agree with you on that one.
That it's B?
Yeah, sorry. I was thinking that our level of significance was our number we got in 26, and we were comparing it to, and our p-value was 0.10. So I was backwards. I was like, we don't have enough information. Sorry, I was just backwards.
No, you're good.
Okay. So
well, see how we did? 100%, guys.
Really?
Yep.
Awesome.
Wow.
That's great. That's great. That's good. Good.
Good job, team. Back.
Oh man. All right. Sweet.
All right, guys. Well, so for next week, we have to start thinking of
our project.
Yeah.
So I've seen lots of people do these projects. A lot of the times what they'll do is they, I don't know if you guys have seen them do it, but they'll go to like a store and they'll get like 5 bags of Skittles or M&Ms or something like that, and then their hypothesis is like, I suppose there's going to be this many brown M&Ms or something in there, and then you actually go and you see, and then somebody else with the alternative will be like, I agree with you, or it'll be like, I think that it's going to be less than the null hypothesis. I think there's going to be 5 instead of 6. And then you just get 5 bags and you check it, or something like that. I don't know. I don't think it's super hard.
I want it as easy as possible.
Okay. But I don't know. I'll ask some of my friends that did it a couple semesters ago and see.
Okay, so
some ideas.
All we do this week is it says you and your group will complete a final project together. We know. The project is divided into 7 steps. The first 5 steps are the same steps we've been seeing in the readings. Each of the 6 steps will be written up by different members of your group except for step 2. Everyone will write and upload their own document. So all we have to do is decide who's going to do what for this next week.
Oh.
So we don't have to decide on it quite yet. We just got to divide it all up and begin working on it, I think.
Okay.
And I'll create a document and submit it for all of us. So there's not too much we have to do quite yet.
So that's the only homework we have for next week?
Well, that aside from the 2 normal activities we do.
Oh, so there's there's just extra.
That's just the extra thing.
Well, fun.
So Tuesday morning, does that work for everyone?
Yeah.
I think so, yeah. I don't think I work that day, so.
Okay. I know I work. That's when I get off, so.
Okay.
It's just easier before I go to bed.
Okay. All right. Well, thanks, guys. Appreciate your help.
I'm taking it right now, so.
You're doing what?
I'm going to take the test right now, so good luck, guys.
Oh, my gosh. Let me know how you do.